Hi everyone, welcome back to Chem Help ASAP. In this video, we are going to talk about the most important lesson you learned in preschool, sharing. Now, we are not talking about sharing toys or crayons, although that is important. We are talking about atoms sharing electrons, lots and lots of electrons. Now, if you haven't already, I do recommend checking out my video on Lewis structures with just single bonds. But once you're ready, let's jump into some multiple bonds and start sharing electrons. In the spirit of sharing, I'm going to take our rules for Lewis structures and I am just going to add a modifier to our rule number 3. So like we saw in the previous video, rule number 3 is we're going to start by sharing one pair of electrons between atoms. However, our modifier states that if octets are not satisfied when you shared one pair, then you need to make the atoms share more. So let's start with a very familiar molecule. Let's start with carbon dioxide. Okay, just like before, we are going to start by adding up valence electrons. So carbon gives us 4 valence electrons. I have 2 oxygen atoms. They each give me 6 valence electrons. So I have 16 valence electrons. Looking at the molecular formula, carbon is written first and it is a single atom, so I'm going to put it in the center. And I'm going to put oxygen on either side of carbon. Okay, we will start by sharing one pair of electrons. 1, 2, 3, 4. Okay, that's fine. I still have 12 valence electrons to work with. I've used 4, so let's try to satisfy octets with my remaining electrons. So I've used 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and I have run out of valence electrons. Now, the temptation here is to just keep drawing your dots until everybody has 8, right? But the problem is these 2 pairs of electrons do not exist. We only have 16 valence electrons. So you cannot conjure up electrons out of thin air. So those pairs of electrons I am going to erase because they are not there. They do not exist. Okay, let me change colors. And let's see if everybody's octet is satisfied. And I think you know where I'm going with this. Okay, so this carbon here, yes, has 8 valence electrons. It's fine. This oxygen also 8 valence electrons. It's fine. This oxygen, however, only has 4 valence electrons. Its octet is not satisfied. This is not a valid Lewis structure. Okay, so we need to find another arrangement of electrons that is going to satisfy the octet for all 3 of these atoms. I'm going to redraw my structure. Let's do the carbon and the oxygen. So the modifier to my rule stated that if sharing a single pair of electrons does not result in satisfied octets, I need to make the atoms share more electrons. So let's take this carbon-oxygen bond, and instead of sharing one pair, let's make them share 2 pairs of electrons. So that's 4 electrons, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, and those are my 16 valence electrons. Let's switch to green and see if my octets are satisfied. Okay, so I'll start with carbon here. 2, 4, 6, 8. Yes, good, octet. This oxygen 2, 4, 6, 8. Yes, octet. This oxygen 2, 4, 6. No. Okay, so this oxygen here that I've just circled does not have 8 valence electrons, so this is not a valid Lewis structure. However, what I notice is it is better. We are closer, but we're still not quite there. So if sharing 2 pairs of electrons helped me, I'm going to make that other carbon and oxygen share more as well. Redrawing the structure, Carbon, oxygen, oxygen. Okay, let's make each bond share not 2 electrons, but 4 electrons. So let's see, now I've used 8 electrons, 9, 10, 11, 12, 13, 14, 15, 16. Okay, I've used my 16 valence electrons. Let's see if octets are satisfied. Okay, so this carbon, 2, 4, 6, 8, yes. This oxygen, 2, 4, 6, 8, great. And this oxygen, 2, 4, 6, 8. Okay, so each atom has 8 valence electrons. The octet is satisfied. This is my valid Lewis structure. Now let's write it a little prettier without these circles. And I'm also going to convert to writing bonds. So instead of drawing out the 4 electrons in between the carbon and oxygen, I have put in 2 lines to represent a double bond. Now let's do the Lewis structure for nitrogen gas. That is N2. Nitrogen has 5 valence electrons, so I have a total of 10 valence electrons. So this one's kind of easy. There really is no central atom since it's just 2 atoms bonded together. Okay, so let's make them share. So we have 2, 3, 4, 5, 6, 7, 8, 9, 10. Switch to green. Let's see if we've got octets. 2, 4, 6. That's not good. How about this one? 2, 4, 6. Also not good. Okay, so not a valid Lewis structure. Let's try again. Nitrogen and nitrogen. Sharing 1 pair of electrons did not work. Let's make them share 2 pairs of electrons. So I have 4, 5, 6, 7, 8, 9, 10. Okay, let's see if octets are satisfied. 2, 4, 6, 8. Okay, that nitrogen is good. 2, 4, 6. Oh, nope, this nitrogen also not good. Okay, so sharing 2 pairs of electrons didn't work. You can probably guess where I'm going with this. Nitrogen. Let's make them share 3 pairs of electrons. So that's 6 electrons. We have 8, 9, 10. Let's see. 2, 4, 6, 8. Okay, great. 2, 4, 6, 8. Okay, so here is my valid Lewis structure. Each nitrogen has 8 electrons. Its octet is satisfied. Let's rewrite this a little prettier. So we have nitrogen. We are sharing 1, 2, 3 pairs of electrons, and each nitrogen has a lone pair. This, as you might guess, is called a triple bond. Now, something I want to point out, you can see in my first Lewis structure, I had my lone pairs at this point in the nitrogen, and then I switched them over here. That is really just personal preference. You can put those lone pairs wherever you want as long as you show them around the atom. Let's take a look at sulfur dioxide. Okay, we'll start by counting up valence electrons. Sulfur has 6 valence electrons. I have 2 oxygens. They also have 6 valence electrons. So I have 18 valence electrons. I'm going to put sulfur as my central atom. So sulfur, oxygen, oxygen. Okay, I'll start by sharing 1 pair of electron. So that's 2, 4, 6, 8, 10, 12, 14, 16, 18. I don't think this is going to work because I can already see that that oxygen only has 6 electrons. Okay, so no good. Let's try again. Sulfur, oxygen, oxygen. 2, 4, 6, 8, 10, 12, 14, 16, 18. Here, let's make that one electron a little bit bigger. He was kind of hiding. Okay, let's check now. 2, 4, 6, 8. Okay, great. 2, 4, 6, 8. Yes. 2, 4, 6, 8. Fantastic. Let's redraw this with bonds. I'll switch to my purple. So that is oxygen, double bonded to sulfur, single bonded to oxygen. And I have a lone pair on the sulfur, 2 lone pairs on this oxygen, and 3 lone pairs on this oxygen. Now, this brings me to another concept. I have drawn this Lewis structure such that the leftmost oxygen is the one that carries the double bond to the sulfur. But what if I had written it the other way around? So here's my sulfur, oxygen, oxygen. What if that was the single bond, and this was the oxygen with 3 lone pairs, and this one had the double bond? Is this still a valid Lewis structure? Well, yes, because the octets are satisfied for all of the atoms. So when you have more than one option to write a valid Lewis structure, they are called resonance structures. And we put brackets around them. And we draw a double-headed arrow between them. I know that Lewis structures can be tough and intimidating the first time you do them, but trust me, the more you practice, the easier they'll become and the faster you can draw them. Now in this video, we stuck only to neutral atoms. In my next video, we are going to talk about charged species and how to do Lewis structures for polyatomic ions. So I hope you'll join me. Thanks so much for watching.